Hello, everyone, and welcome to my online presentation. This is kind of a strange time. I heard something kind of funny the other day. It was something someone sent me, and it rang true to my ears. It said something like, my hair is long, and gas is cheap, and I'm grounded. I feel like I'm a teenager again. I think that pretty much sums up how I grew up. Let's jump into this lesson. I'm going to hide myself. You've seen enough of me, but obviously you know that I am very dedicated to working in the environmental sector and working on um, climate change and helping people, young and old, understand a little bit more about the science behind climate change and looking at what we might be able to do to help promote a healthier, more sustainable world, so that it'll be there for those that we love, the ones who will come after us, our children and our children's children. So, okay, here we go. Bear with me while I pull this PowerPoint up, and I will share this out. Bigger for you. And here we go. So as I said, my presentation is on presenting a lesson that will introduce learners to the issues associated with climate change. Here's my learning objectives for this lesson. I hope that by the time we're done with this, upon completion, all of us, the participants and self included, will be able to articulate the complicating sources and factors that tend to spur a debate around climate change science, and also that we'll be able to define climate change, because it means different things to different people, but we'll look at what the accepted definition of the field is, and we'll identify the difference between climate and weather. This is something that's often confused. We'll look at and identify and describe, hopefully be able to identify and describe the causes and effects of climate change. We'll be able to define greenhouse gases and the importance of them in our Earth's balancing of radiation. We'll also look at what happens when we overproduce greenhouse gases and how that can be very detrimental and is contributing actively to a warming planet. And then finally, I'll encourage you to explore your own carbon footprint using one of the many carbon footprint calculators that are out there. And by doing this, we should be able to then identify ways in which we can live a little more sustainably. So let's talk about what is climate. As I mentioned, many people confuse, and this is young and old people, confuse the terms weather and climate. When we look at the difference between weather and climate, we're actually looking at one major factor. And I'm sure many of you have thought of it already. My picture is probably blocking it on the screen there. But the main I didn't do that intentionally, but it worked. The main difference in defining the difference between weather and climate is actually time. When we look at weather, weather describes atmospheric changes that occur over, a relatively short period of time. So minutes to weeks in duration. Climate, on the other hand, and climate change describes atmospheric changes over long periods of time, such as years or decades or centuries. And so when we are talking about weather and climate, with climate, we're looking really at weather patterns and averages over long periods of time. With weather, we're looking at relatively short and sometimes extreme changes that can occur. A cold front that produces really cold temperatures, and then 2 days later in South Florida, it's 95 degrees. Okay, so we see these big fluctuations that occur. Obviously, you're not in a classroom setting, but think for a few minutes of an example, if you can, between the difference between weather and climate. Come up with a weather change. I gave you one just a minute ago, but then come up with a climate change. So hopefully you came up with something like, over a long period of time, a higher temperature pattern could be considered a climate-related change, where an increase in temperature for a day or a week, or maybe even 2 weeks, is really considered more of a weather pattern. And what we need to understand is that climate affects many, many things. It's not just temperature. We also have to look at things like precipitation, how much rain we get or don't get. There's also strong connections to climate related to currents, ocean currents and wind currents, and we'll talk about that in a little bit. All right, so which of these do you think is easier to predict? Well, if you said climate change or changes in the climate, you'd be absolutely right. Because climate change is a long-term average of weather, as we mentioned. So it has a much more gradual change, and it makes it easier really to predict, where weather fluctuates. Did you ever hear anybody say, even the weatherman doesn't know what the weather is going to do? I used to see this more so even up north when I was living there, because we had, here you have somewhat of a temperate climate, but up there we had extreme differences, especially this time of the year. For example, my mother called me yesterday morning from Pittsburgh, and last week it was almost 60 degrees there, and she called to tell me that she had a light dusting of snow on her back porch. Sent me the pictures, and also informed me she's not liking the ability to not get on a flight and come here. Let's look at the things that make Earth habitable. So the Earth's distance to the sun and the path in which the Earth takes around the sun affects the amount of radiation, which in our case we interpret many times as heat. It affects the radiation that reaches Earth. If the Earth were a few degrees one way or a few degrees another way on an orbital path, it could have intense effects. But it's quite systematic, quite a logical, natural system in place. Pretty amazing system. Then we have to consider the angle of the Earth, the Earth's axis and how it tilts. This allows for, the Earth to be heated in different areas. So obviously something around the equator or the center line of the Earth would be a lot warmer than maybe one of the poles of the Earth. And it's really interesting when we start looking at those currents that I talked about and how this design to heat the center of the Earth plays into those currents, which actually work, if you will, as like a conveyor belt to take energy from one place and move it around the entire planet, either through wind current or through ocean current. And then there's a thing called the Earth's albedo. When we talk about albedo, we're really looking at the ability for the Earth to be able to reflect radiation. Albedo is the amount of reflection in most cases, planet, but a surface has in terms of being able to bounce off radiation. And so, when we look at this reflection, anything that would impact or impede that reflection could throw the system out of whack. The molecular composition of the Earth's atmosphere, and we're going to go into the Earth's atmosphere a little bit so you get an understanding of that, because it's really pretty, again, amazing. And then the currents, as I was telling you, which we call that energy transfer, how the currents move energy or radiation, heat, if you will, around the planet. And then the term biosphere is something that we should all be really using when we talk about the planet Earth, the area that we live in. Because the biosphere is really, so far we've found nothing like it anywhere else in the universe. And what it really is it's that area of containment where life can exist on the planet. So the biosphere in our particular case is probably a better term to use than just stewarding the Earth. Really what we're doing is we're working to steward the biosphere and to protect the biosphere. Let's talk about a little bit of science on the atmosphere and the gases in the atmosphere. And you may remember this from science class many, many years ago. I had forgotten all these layers, but I thought it was a great review for us. So I thought we'd share them. The first layer, if you will, is the troposphere. And the troposphere, it's interesting because, I used to think when I was younger that as we increased altitude, I used to think we would decrease temperature. Like it would get colder. I remember going up in a plane and it would be colder. If the plane wasn't balanced right, it would be colder the higher we went. When you climb a mountain, you feel that change in temperature. Well, now I know, and many of us know, that they actually alternate. So it gets colder in the troposphere, and then when we hit the stratosphere, it starts to heat up. And then it cools back down in the mesosphere, and then the thermosphere obviously gets very, very cold when we move out towards space and the exosphere. And those temperature connections are very important and very important part of the balance of the system. So when we look at our atmosphere, and in this particular case, we're going to focus on that first layer, the troposphere. We know that there are gases that exist in this layer that are natural, and they're there on purpose. These are things like nitrogen, oxygen, carbon dioxide, argon, lots of water vapor, excuse me, and other trace amounts of various gases. Greenhouse gases are gases that are capable of absorbing and remitting infrared radiation. These gases can grab hold of radiation and hold on to it, and retain its heat, and then push it back out, remit it. The common greenhouse gases in our atmosphere are listed right there for you: water vapor, carbon dioxide, methane, nitrous oxide, ozone. You remember years ago we were having problems with ozone. Now, in balanced amounts existing in nature, these gases are required. They're actually needed, and they're good because they control and regulate the amount of radiation or heat, energy, that reaches the planet. Now, what's happened, because Greenhouse gases absorb and retain heat, and they can trap heat in the lower Earth's atmosphere. If we have a huge increase, or we somehow produce an out of balance of the gases, the greenhouse gases existing in our atmosphere, then we trap that. There's more gas holds on to more radiation leads to more heat, and we trap that. And therefore we end up creating a warming surface temperature, in this case, of the planet Earth. And we'll talk about the effects of that in a few minutes. So anthropogenic, which is just a big fancy term for, created by humans, or man-made, woman-made, human-made. Anthropogenic increases in these greenhouse gases due to things such as like burning. Major one is burning fossil fuels. It increases this heat-absorbing gas, and it's leading to a creation of a warmer planet. And what's of special concern, and why maybe the focus before the 19th century wasn't as strongly, there wasn't as much concern, is because during the industrialization period and over the technology revolution period that we've gone through, we are now seeing a tremendous spike in heat related to climate over longer periods of time. And scientists connect this to, obviously, the increase that we have contributed to the greenhouse gases. There's an interesting video. I'll play it for you. And it's interesting because it really shows much better than I can explain these gases in the atmosphere and how they act.
Hi, this is Bill Putman. I'm a climate scientist at NASA's Goddard Space Flight Center. What you're looking at is a supercomputer model of carbon dioxide levels in the Earth's atmosphere. The visualization compresses 1 year of data into a few minutes. Carbon dioxide is the most important greenhouse gas affected by human activity. About half of the carbon dioxide emitted from fossil fuel combustion remains in the atmosphere, while the other half is absorbed by natural land and ocean reservoirs. In the northern hemisphere, we see the highest concentrations are focused around major emission sources over North America, Europe, and Asia. Notice how the gas doesn't stay in one place. The dispersion of carbon dioxide is controlled by the large-scale weather patterns within the global circulation. During spring and summer in the northern hemisphere, plants absorb a substantial amount of carbon dioxide through photosynthesis, thus removing some of the gas from the atmosphere. We see this change in the model as the red and purple colors start to fade. Meanwhile, in the southern hemisphere, we see the release of another pollutant, carbon monoxide. This is a gas that's both harmful to the environment and to humans. During the summer months, plumes of carbon monoxide stream from fires in Africa, South America, and Australia, contributing to high concentrations in the atmosphere. Notice how these emissions are also transported by winds to other parts of the world. As summer transitions to fall and plant photosynthesis decreases, carbon dioxide begins to accumulate in the atmosphere. Although this change is expected, we're seeing higher concentrations of carbon dioxide accumulate in the atmosphere each year. This is contributing to the long-term trend of rising global temperatures. Orbiting Carbon Observatory 2, or OCO2, will be the first NASA satellite mission to provide a global view of carbon dioxide. OCO2 observations and atmospheric models like GEOS-5 will work closely together to better understand both human emissions and natural fluxes of carbon dioxide. This will help guide climate models toward more reliable predictions of future conditions across the globe. Hi, this is Bill Putman. I'm a climate scientist at NASA's Goddard Space Flight Center. What you're looking at is a supercomputer model of carbon dioxide levels in the Earth.
Sorry about that. You almost got to watch it twice. So let's take a look at some of the world's top carbon dioxide producers. And really, it's probably an easy question. You know, when we say, who do you think is some of the top producers? And it's usually those countries that have the highest levels of industrialization, of technology, of consumerism. And you can see here that the US is only second to China in the amount of carbon dioxide that we produce, carbon emissions that we put into the environment. So what are the sources and types of these greenhouse gases? You can take a look here. You can see carbon dioxide is a large one that's produced by fossil fuels, as I was saying, almost 65%. And a lot of that is really being burnt for energy sources to create electricity and or fuel. Methane, which is a significant amount of that is produced. Some of that is produced by manure, human waste, cow waste, those types of things, animal waste, and then carbon dioxide from. They have another category here: forestry and other land uses. But then, looking on the right side, you can kind of see by sector which of those areas, and you see that transportation and electricity are two of the largest. I mean, you put those together and we're over half of the greenhouse gas emissions. And then you add to that industry. So again, it's pretty easy to see. All right, time for a little reflection and your thoughts. I'd like you to take 3 minutes, and in those 3 minutes, I want you to write down every effect of climate change that comes to your mind. So anything that you think is a cause, or not a cause, is a result of climate change, put it down on your sheet, and maybe a word or two explaining why. And we're going to group share this out. We'll see who gets the most. Your time starts now. And for purposes of this video, I'm going to go ahead and move forward, but hopefully you will had all of those, and you'll be able to share out with me on the discussion board that process. So here's some of the major effects of climate change. The South Florida Climate Action Plan, the Regional Climate Action Plan, highlights these very well. So if you want to go and check that plan out, we are actually fortunate in South Florida that we do have a very progressive 3-county coalition of Miami-Dade, Broward, and Palm Beach. And this coalition has been working on climate action planning for several years. Their first plan was put out in 2012, and that same year, President Obama actually held that plan out as a model to the rest of the nation. And, so people often think that there's not a lot going on because they haven't heard about it, that government isn't doing enough or communities aren't doing enough. And really, I think in some cases they're doing a lot. It's just not being communicated real well. But we do know these effects of climate change. Sea level rise, melting polar ice caps, urban infrastructure and health risks. Looking at increased flooding in coastal and low-lying areas, and it doesn't have to be sea level flooding. It can be rains, intensified storms in low-lying areas, or a poor infrastructure system, sewer and water drainage systems. Transformation of natural ecosystems. I'll give you one example in South Florida, mangroves. We're seeing mangroves disappear, and mangroves are really a buffer between salt and fresh water. They're also erosion control mechanisms. And so, when we see this, and in many cases, it's because of clearing for habitat. Clearing habitat for building, new construction, those kinds of things. Economic and health risks, especially for our agricultural communities. If you have not traveled out to the Glades, it's an eye-opening experience. I've been doing some work out there with a bunch of different community, smaller groups, and it truly does identify and it exposes some of the major health risks in those agricultural communities. Increase in disease. This is like kind of right in line with what we're talking about right now with this whole pandemic. Although in this particular case, we're talking about disease that's carried by insects, in many cases mosquitoes, but other types of bugs and insects. And as we see more areas having warmer temperatures over a longer period of time, we see the prevalence of increase of disease-carrying insects. Increased frequency of hot weather temperatures, very hot zones, if you will, hurricane and storm intensification, risks associated with sea level rise and storm surge. And again, this report that the RCAP put out talks about the projected increase in the level of sea water and what that looks like for specific areas in our area. And then, obviously, water. I left out invasive species, but you just got to look at the Everglades to see that, both plant and animal. But the threatened fresh water quantity and quality. Water is really going to be a significant commodity as we move forward. So let's discuss for a few minutes in small groups, although we're not really in groups, but just for your own perspective, maybe you can jot this down. And then if you, again, want to send me a note or a comment on this in the discussion board, that would be wonderful. But how do the following influence climate change perspectives in the United States? Because we would think that with all this information, everybody would understand the science and they would want to make these changes. But there's some very real things at play. Politics, for example. And it's strange that in our country, climate change has really taken a polarizing effect when it politically, when really it's an issue that should concern both sides of the aisle. But for some reason, and it's not that way everywhere in the world, and a lot of it has to do with economics, the economics of consumerism and capitalism. And so, in the politics at play around that. So the economics come into play. And then media is a reinforcing agent of distress. So the media likes to, I read a very good article by Boykoff and Boykoff, I believe it was, where they looked at like a 20-year period of what the media reported about climate change. And what they found was, while there was an enormous amount of agreement among scientists, the articles and the stories that were pushed out were focused more on that debate or that disagreement. And so, the media tends to operate on what they call journalistic norms. That's what this article was about. And these journalistic norms look at dramatization and looking for things that are not in agreement and congruence as opposed to those things that really are. And so how does the media affect these perspectives? I think it's a good question for you to take away and think about. So how can we help? And we'll end with this. There will be future lessons that I'm working on in this curriculum plan. And for the next lesson, we will look at like our personal lifestyles and how, it may seem like sometimes like we can't do anything, but really there are things that we can do. And so I would leave you with this, that maybe there's a lot of these out there, but maybe you go in and check out one of these, see if I can get this to work, one of these carbon footprint calculators. I really liked this particular one because it was pretty easy to navigate through. And then it actually calculated how many trees your lifestyle would require. So it was kind of a neat piece. And so I think maybe that's our takeaway lesson. And again, if you would like to put that into the discussion board, I'd be very interested to hear your number if you want to share that with me. And some of us may not, because we may realize, though, from this process that there's some changes that we would like to make to try and personally be more responsible when it comes to sustainability. Future sessions are going to look at resiliency, looking at climate change mitigation, and climate change mitigation is a word you all know about right now. What we do to alleviate the effects of climate change, just like mitigation of the coronavirus is what we do to alleviate the spread. And adaptation. Adaptation are those physical types of changes that need to occur in communities, because we know that there are going to be physical changes as a result of what's already occurred with the climate changes over periods of time. I just want to wish everyone, well-being and safety during this kind of chaotic time. I look forward to the time when we can all engage and interact personally again. And until then, this is the best we have. And I appreciate your time and your feedback. Have a good day.